Java is most widely used programming language. Java has consistently held the number one slot since 2004 in terms of popularity, which is evident from the fact that 90% of the Fortune 500 companies use Java. In this session, we will learn the best practices which you are going to use for the rest of your life as a Java developer. By the end of this session, you will be having a strong foundation on which you can build something substantial. Now let's talk about the agenda. First, we will be covering what is Java, then history of Java, Java's Hello World program, features of Java. Then we will cover JDK, JRE, JVM, variables, operators, data types, conditional statements, loops, branching statements, comments, objects and classes. Then we talk about constructors, super and this keyword, inheritance, runtime polymorphism, compile time polymorphism, that is method overloading and overriding. Then we will talk about abstract class, and then we will talk about interfaces, then the exception handling, and finally we will conclude this session on strings. So now let's talk about what is Java. Java is a high-level object-oriented programming language that was originally developed by Sun Microsystems. What do you mean by high-level? Basically, there is a thing called low-level and high-level. Basically, in low-level language is much closer to machine code or assembly language where there is zero or little abstraction, right? We can't hide things that are, what abstraction means, basically hiding the unnecessary information, giving what is required, right? There was no such thing in low level language. So basically in Java, there is a strong abstraction, right? So this is a high level language. What do you mean by object oriented? Basically, there are 4 pillars of object-oriented, right? Abstraction, polymorphism, inheritance, like all those things are there. We will cover all those things later in this course, but right now we just need to know that it is object-oriented programming language, right? It follows the principle of VORA. What do you mean by VORA? Write once, run everywhere or anywhere. Right? You can run it anywhere. You can run Java program as many times as you want on a Java supported platform after it is compiled. Right? There is no need for recompilation. That is what you mean by VORA. Now let's talk about history of Java. Okay. So earlier in 1991, Java was first designed for digital cable television industry, right? It was initially known as Green Team. Later it got renamed to Oak, based on an oak tree outside James Gosling's office, right? So they used to drink or they used to have lot of coffee, right? So in 1995, this oak got changed to Java based on an island in Indonesia from which the team used to have coffee, right? So in 1995, Java was the name given to oak, right? Java was also included in Times magazine for the top 10 best products of 1995. In 1996, we got JDK 1.0 got released, right? What do you mean by JDK? It's a Java development toolkit, right? Or kit, what do you call it? We will cover this thing also later in this course, but in 1996, we got this JDK 1.0. Now let's talk about this first program. Before we move ahead, I know this is too early for this program, right? But you need to have certain kind of an idea to understand the things that we are going to cover later in this section. Okay, so here you can see there's something written public, then it is a class, my first code, public static void main, and there are in arguments I have written string args, right? And then system.out.println and hello world. So to brief everything about it, we will cover it, but to give a little bit of overview what this is, how it is written, what does these lines of code mean, I will give an idea about it. Basically, what do you mean by public? It's an access specifier, right? For example, if something is public, you can access it anywhere, right? Anywhere in your code. So if it's private, but within a class, you can access private things also. Those things will be covered. But for public, you must know that it is public to everyone. You can access this class from anywhere. Okay, so then there is a class, this is a keyword, right? Then the name of the class is given as my first code, right? Then there are certain then there's a function, main function, right? Public static void main. Void means that it returns nothing. Static means it belongs to a class rather than to an object, right? We will cover all those things. You don't have to worry right now. Just to give a brief idea what these lines are mean, because this is a skeleton, or what we call a boilerplate for Java, right? Then there's public, again we have covered it. Then in arguments there is written a string, right? args. Then to print anything on our screen, we just have to write sop. What is called it, what do we call it? It's system.out.println. Okay, then in strings we have hello world. This program will print out as an output hello world. Okay, so now let's brief about these lines. Everything bold in Java is a keyword, right? It has some fixed meaning, right? Right? My first class, the class was declared by the name my first class, right? The name of the class was my first code, right? Class is used to declare classes, right? This class keyword, which we saw earlier in the slide, is used to declare classes. Okay, then public is an access modifier which allows visibility to all. Okay, then static doesn't need object to get called, and main gets called by JVM. This main method is called by JVM. It doesn't need an object to call it, right? If we will cover these things when we run our program, we just write the name of the program and that's it, right? Java, then the name of the program. So we don't create any object for this main method, so it's called by JVM. Void, we have already covered. Void means that we are not returning anything. Now, since we have understand the code, what we have shown earlier, now let's see some basic things. Before we move ahead, before we compile it, we need to have some kind of software, right? So you can just go into the Google and just write download free Java software. Then there comes up the first link, then click on it and just download the version you are going to see, or the current version that right now is present. You just download that. We are not going to use any IDEs like Eclipse, NetBeans, BlueJ, JEdit. We are not going to use those things because in these IDEs life gets easier, right? It's easy to write code in that, but we are starting from the scratch, and this course is for beginners. We are going to use IDE, right? But on the Geeks for Geeks, right, to make things simpler for us. But if you don't want to use that, you just download this, and we are going to use Notepad or Notepad++. If you want to use, you can use those things, right? So it makes our life easier, and it makes us understand the things much efficiently, and much we are going to think about all the lines that we have written. Nothing comes up for us by default, right? We have to write everything by ourselves. So after doing that, once it's downloaded, you have to do two things, right? You have to set up environment variables. What do you mean by those? Basically, we have to set path and class path. Okay, we need to these. I'm repeatedly saying that we need these variables too. We need to set these variables. Okay, without these variables, our program will behave will not behave in a proper way, right? So if you're expecting something out of your program, it will give undesired outputs, or it may not compile, or it may not run, because we haven't set those variables. So for those variables to be set, if you're using Windows, you just go on to you just open your control panel, right? Then you just go on system, right? Systems. In that systems, go on to advanced settings, right? I will show you quickly. 1 second, let me show you this thing. Here it is. Okay, so yeah, advanced system setting, go into this thing, right? Click on it. Okay, just give it some time. Then go to environment variables, and then if you haven't seen or if you don't see any variable name path, then create it. If you see path variable, you need to edit it. Once you did this, once what do we have to edit here? Basically you need to go into the folder in which your Java software is downloaded. Basically it will be downloaded in your C drive. Then you have to go into program files, then go into Java, then go into JDK, right, or the version will be included with it, right. Then go into JDK, then go into bin, then paste the path here. Okay, just write semicolon, then paste the path of JDK here in the path variable, right. Then also paste the JRE of below that JDK, there will be JRE, right. Also include that path in this after semicolon. So why do we need to set this path variable? Basically it is used by the operating system to locate the executable files or Java binary. Basically if you want to run Java or Java C command, basically to compile and to run these commands, if you want to run these commands, you need to set the path variable. Also we don't have to write the exact code. What helps after setting these variables, what help do we get or what benefit do we get? We don't have to write the exact path in a command prompt. Okay, basically everything will run through the command prompt. Okay, here it is. If you can see the command prompt, everything will be run here, right. Even if my this Java is stored in this thing, right, in C drive, right. If in this folder of Azan dot that anything in this folder my Java file JDK is downloaded, right. But after setting up the path variable, I can run Java command from anywhere, right. You see, if I run Java, it didn't give me any error, right. So it cannot be, if a path variable is set, it cannot be overridden. Okay, so why do we need class path? Basically it's used by application class loader to locate and load the dot class files. Basically when an application requires some directories, right, all those directories are fetched for us with the help of class path variable, right. It contains all the dot class files and jar files required by the application. Classes are when the classes are loaded at runtime, these classes are loaded by JVM. Okay, also once the class path, as we know, path variable cannot be overridden, but the class path variable can be overridden. Okay, so these are some things that you should know. And now let's go back to our thing which we had. Okay, there it is, right. After setting up our environment variables, now open the command prompt, right. Then type JAVAC, right. This means that we are compiling our my first code.java. Basically once it is compiled, once we don't get any error messages, or if we get, we need to resolve those. If our program executes fine, then we go on and write Java my first code. These are the binary files I was talking about, right. Java binaries. Basically these help for the first command helps us to compile, and the second command will help us to run our code. Then our output will be hello world. Okay, so these are some things. Then before we get started, there was a line called system.out.println, right. What do you mean by this line? What does this exactly mean? Basically system is a class, right. It's a final, the type of it is, or the keyword associated with it is final. That means it cannot be changed. So system is a class. It is in a package called java.lang. Okay, so the facilities that this class provides are input, standard output, and error output stream, and many more. So basically if you want to print anything, you need help of this class. Then there is out. So out is a static field of a system class. Okay, static field. What do you mean by static? This thing will be covered. Basically static means a thing that is not associated with your object, rather it is associated with a class. So if you don't create an object, you can still access this variable or this field or this member with the help of its class name. So that's what we are doing here, right. we are accessing it with the help of a system class. So this is also a system, and it is of type print stream. Okay, this is a type that is associated with out. And then there is a print ln means that we, every time we print this hello world, then the next time if you are trying to print anything, it will start from the new line. Okay, so println is a method of print stream class. Okay, you don't have to, I mean to say, you don't have to go in depth right now, because this course is for since for only for beginners. So you can, if you want, but if you don't understand anything, you don't have to worry, right? You just need to understand that this thing is needed whenever we are trying to print anything on our screen. Okay, that's it. Now let's move ahead, and now once our code is compiled, then we will get this output that was written in this SOP or system.out.println, that hello world. Okay, now let's talk about features. This is the most important thing, that why we are using C, why we are using Java, right? So we had C, we had C++, right? Why we are using Java? First thing is simple. It's very easy to learn, as a syntax is familiar to previously existing languages like C and C++. Since we have, if we had any we have done any coding, or we have done any kind of programming in C or C++, this syntax is familiar to that. It's much more easy to learn this language. If not, no worries. Once we will complete this course, all the things will be clear as a crystal. Okay, and then second thing, it's object oriented. Java is based on objects, which imitates real world problems, right? It supports the 4 pillars of object oriented language, right? What are those? Inheritance, polymorphism, abstraction, and encapsulation, right? These things will be also covered, right? Right now we just need to know the features, right? It is object oriented, it's simple. Then the third thing is that it's platform independent. What do you mean by this thing? It has an own virtual machine, right? We will talk about what does this thing mean. Basically, it means Java virtual JVM, right? Java virtual machine, right? It has its own JVM or virtual machine, and it converts the code into bytecode, which can run in any Java supported platform. That's what we mean. That's when we are talking about in the first slide that run Vora thing, right? The Vora, write once and run anywhere. So basically it's a platform independent language. It's secured. Java is way more secured because it has its own box responsible for handling its execution, right? What is that called? JDK. Okay, it does not support pointers. Basically in C++ we had pointers, right? In C we had pointers, right? So basically when we are dealing with pointers, we are dealing with addresses, right? If you somehow mismanage those pointers, that can lead to a fatal error message, right? Fatal things, right? If we are not allowed to edit or to manipulate any address we did with the help of pointers, right? Multiple inheritance is not here, which caused ambiguity or led our programs to crash, right? What do you mean by this thing, multiple inheritance? So basically if you are inheriting some properties from your parent class, right, then two classes are there, right? So both of them are inheriting from the same class, right? So basically that problem is called diamond problem. Then if someone accesses, for example me and my brother are inheriting from my father, right? So if we try to access, for example, some of his properties, like in his hair, right now it doesn't make any sense, but let me just put it in a naive way. So when two people are accessing the same variable, right, me and my brother are accessing the same thing, and I manipulated it, right? So he also manipulated it. But so what I am thinking, that I have changed this and this is the value that I am expected to print, right? So but my brother also changed it, right? He also changed this variable, right? He has inputted his own values and he's expecting that output. Okay, for me it has been changed, right? This is the ambiguity, right? I am expecting anything, he's expecting anything, right? This ambiguity, where whatever the ambiguity caused by any previous programming language or any in Java, whatever the ambiguity is there, it was not supported by Java. It's much more efficient, right? Because it uses JIT, that is just in time compiler, that basically utilizes the best of the two worlds, that is the compiler and the interpreter, right? And the best thing about the compiler and the interpreter, these two worlds are different worlds, right? But JIT provided best of these two worlds, right? The compiler, what compiler used to do, and what interpreter used to do, the best features of these two things was involved in JIT. Okay. Now, multi-threading. Java supports multi-threading, that basically allows multiple tasks to execute concurrently without occupying much memory. You might have seen when we are using an editor, there is a thing going on internally. What thing? That, for example, I am typing some essay. Let's suppose I am typing some essay. Now, internally, the grammatical checks and the spellings are checked, right? This is called multi-threading. This is a naive example of multi-threading. So basically I am doing one task, so concurrently there are several other tasks happening on that particular task, right? So I am writing, concurrently there is a spelling check going on, the grammatical mistakes, if there are any grammatical mistakes, that has been also checked, right? So these all things are multi-threading. Now let's move ahead. Now let's talk about JDK, JRE and JVM. Until this point I have used these words many times, like JDK, JRE and JVM. Now first let me show you this image. This image is very important. The bigger box, that is JDK, is the Java Development Toolkit, right? And the inner box, that is JRE, is the Java Runtime Environment, right? And inside JRE we have JVM, some libraries and development tools. Okay, now let's go back. So JVM, Java Virtual Machine. There is no such thing as JVM, right? What do you mean by this thing? It doesn't exist in reality. Okay, it's a virtual machine that holds all Java executions. Okay, all the executions that happen in Java are done with the help of this JVM. It also manages memory, right? The heap memory, the stack memory, garbage collector, right? What do you mean by garbage collector? Basically, whenever we use variables and we assign memories, right, we don't deal with such things of like freeing the memory or allocating, which we used to do in other programming languages like memory allocations, then we have to free, like malloc, calloc, and then free the memory. These things are not done in Java. We don't have to deal with this. Compiler will do these things for us. Okay, rather JVM will do this thing for us, right? So that's all about JVM. Now JRE. JRE is the Java runtime environment, right? It is responsible for running pre-compiled Java programs. That means they have been compiled, and now for running them, JRE provides the environment. Okay, it contains all the files and libraries to facilitate, right, running the Java code, right? So this is the thing, that all the libraries attached to our program or files, JRE is responsible for running them. Okay, it can't be helped. We can't do any development in this, but where can we do the development, right? So JDK is responsible for doing out. If we want to do development, JDK is the go-to guy, right? So in JDK we can run our development programs, right? The Java applications can be easily done with the help of JDK. So JDK is nothing but the JRE plus development tools. What development tools are? Commands like Java C, Java, wherein Java is used for running the program and Java C is used for compiling the program, right? We all know that. We have seen the demo, right? So these are all the things that we need to know, right, about JRE and JDK and JVM. So these things are important. Before we start, I just have briefed you about these things. Okay, let's move ahead. This figure, you have to keep this in mind, right? Now the variables. The most important thing in Java is way to store your values, right? If we talk about in day-to-day life, right, if you want to store some water, right, what do you use? We use bottle. If you want to store some maybe cereals and all those things, right, rice, maybe some cereals and all those things, we use a container. Similarly, if you want to store some value in Java variables, right, we have to use variables.
Variable is a name of a memory location where data is stored, right? What do you mean by this thing? So basically, if you have observed in your day-to-day life, we need variables, right? If you're trying to store some water, you need a bottle. If you are trying to store cereals, you need a container for that. Similarly, if you're trying to store anything in Java, you need variables. So for that, there's a specific syntax given to it, right? Data type, var name, and val. What do you mean by data type? What do you mean by data type? Okay, so basically data type is nothing but a way to tell your system that we are storing this type of data. For example, if you're trying to store integers, you write int here. If you're trying to store decimal numbers, you write float, right? If you're trying to store some boolean value, you write bool. So similarly, these data types tell the system that you are storing this type of values. Okay, then the var name depicts its name. For example, if you're trying to store the count of some numbers, right, you write the variable name as count. And it's also a best practice to use the variable name as what follows in your program. Like in, if you're trying to count anything, you write the variable name as count rather than x, y, or z, and then the val represents its value. For example, int x or int count is equal to 5, right? So this is a way to write a variable. Now let's see a demo. So basically, we are trying to create variables in two different techniques, using two different techniques, right? So the first technique is that you write your variable declaration and initialization in the same line. Okay, as I told you that everything in Java is objects, right? Now you see that I have written int roll number equal to 23, right? Is this the way? Yes, it is. How? So basically what we are trying, what we have created here is a object. In Java we have wrapper class, so this int is converted to its wrapper class, that is integer, integer, right? So that happens internally. We don't have to think about it, or we don't have to deal it right now, as this course is only for beginners. So right now you can just say that this is an object, right? With the help of wrapper class we are able to do that. So variable declaration and initialization in the same line, that is int roll number equal to 23. Similarly for the name, first name Adam, right? This is also one way of creating strings, right? We can create this string with the help of new keyword as well. Okay, then variable declaration first, that is int marks, then later we do the initialization, that is marks equal to 89. Then we try to print all these values. Okay, now quickly go ahead and now let's do a demo on variables. Okay, so the first technique was we created a variable count equal to 10. So this is what type of declaration, that is declaration and initialization in the same line. Then if we do another thing like in int div equal to int div, okay, then div equal to 2. So declaring it first and later initializing it. Okay, then if you try to print this thing, how we print our things, system.out.println, we know what the statement does, right? So then we did what we do, count divided by div. So what should be the output? 10 divided by 2, that is 5. So let's go and run this thing, give it some time. You see, output is 5. So this is how we declare our variables by this statement. The first statement is declaration and initialization in the same line. Then this is declaration and then later initialization. Okay, now let's go back to this, right? So this is how we do our things. Now the naming convention. So there has to be a naming convention, right? You can't, I mean to say, if you name a variable with digits, right? 1 2 3. Is that the correct way? No. So for that we need naming convention. So variable name should begin with a letter or dollar sign or an underscore. So this is a valid. If you try to store variables with these types of names, right, the letter, underscore and dollar, then the variable name is valid. First character can be followed. After this, the first letter should be among this line, the first line. Then after that, it can follow any combination of letters or digits. For example, if you wrote underscore name, right, the valid example is given here. So this is a valid variable name. Okay. Dollar address apple 123, not 123 apple, that's invalid. Okay. Variable name cannot be same as a keyword, because those keywords, like what are the keywords? Basically, which have been stored already, right, which have some specific meaning, like int, float, char, double, void, right? These are all keywords, so they have a specific purpose, right? They are special words, right? Those are called keywords, right? So they have a special meaning. So you can't store these, you can't name your variables as keywords. Variable names are case sensitive. For example, if you declared and initialize your variable apple with 1, okay, all are written in lowercase. Now you try to access that apple and you have written all the letters are uppercase. You defined it in lowercase and you are accessing in it uppercase. So it will give you an error that variable undefined, okay, or variable not found or anything like that, right? But it will give you an error. So you have to be very cautious while declaring your variables. Rather, I already told you the best practice is to name your variables according to your program. For example, if you're doing sorting, write your variable name as sort. If you're trying to store some values for a temporary basis, on a temporary basis, you can write your variable name as temp, right? If you're counting anything, you can write it count. So this is the best practice. And if you are showing someone your code, or in the company, if you're exchanging codes, then using this practice, it's easier for them to, to read your program. It makes it more readable, right? So this is the thing. So this is the naming convention we should follow. Okay.
Thing, right? If I try to implement a variable starting from what number, okay, let me quickly go ahead and just put a 1 here. You see, we will get an error message. Why? Because we are declaring a variable name wrongly. We will see the error message. Okay, just give it some time. Yeah, you see, not a statement. Okay, error expected, right? This is the error, right? Ain't a 1 roll number. This is the error that we got. Okay, there's the thing. Okay, now quickly move ahead and go back to this thing. Okay, so this is the naming convention we need to follow. So now, earlier I was you were saying that the static main, right, the static keyword was there, right? So we have variables of different types, right? What are the variable types? Instance variable, static variable and local variable. What do you mean by instance variable? Whenever we are creating an object of any class, right, variable declaration outside any method but within a class. Okay, when we are basically we'll talk about these things, right? When we create a class, then we create an object within the same class, then we try to access the methods and properties in that class with the help of object. So basically this is an instance variable. As we all know, object is nothing but an instance of a class, so these are called instance variables, right? Every object of a class gets its own copy of variables, right? If I have created a class, say let me name it properly, rather, if I created a class of students, right, now I'm creating objects, right? Student 1, student 2, student 3, everything that is within the class, right, within in that class. So there are, let's say, there's an integer name, integer roll number, string name associated with that class, and there's a method, right? If you what do you mean by a function and a method? Basically, a function is nothing that is a function let me rephrase it. Okay, what do you mean by a function is nothing which does a specific task, right? If it's not within a class, then it's called a function. If it's within a class, that is, this function is now in the class, so it's called a method. So every object gets its copy of variables, right? In this object you will get the variables, right? What are the variables? Like int will be associated with this object, student1, the roll number will be associated with this, and the name will be associated with this roll number. Then we can call that method with the help of this variable. So this is the instance variable, whatever we create with the help of objects. Okay, then we have static variables. Static variables are also called as class variables, right? We didn't create any object for the main method, right? Basically, it was a static method, so it can be called with the help of class name. Okay, variables declared as static maintains a single copy in a memory, and it's shared by all the objects of the class. Okay, so wherein instance variable has its own copy, static variables have a shared copy, right? All the members, all the objects of that class will share that single memory, right? There is no copying of memory or copying of variables, right? So it will save us a lot of space. We will see an example also related to this thing. Okay, non-static methods can't access or manipulate static variables. This is the important thing, right? So if something is not static, so in that static method you are trying to access the or manipulate the members which are static, you can't do that. Okay, local variables, a variable which is defined inside a method, falls in this category, right? These are accessible in the scope where it is declared. Okay, for example, if I'm using a variable in the loop, right, for loop, we will talk about that as well. So that scope is, or if we are declaring anything in a if right, if statements, right, if and else, we are declaring any variable in that, it's called a local variable. They are hidden outside of their methods, right? In that method, if you are saying a function, you have declared a variable and then you are trying to access it outside that function, that can't be done because it's a local variable. It has the block associated with it. Within that block you can access that variable. Okay, now quickly see an example of this thing. So the int is an instance variable. Now you will be confused why it's called an instance variable, right? We are not creating any object with the help of new keyword or anything like that, right? Earlier when I started my started talking about the wrapper class, right? When I gave you an idea about this thing, right? So it is converted into, internally it's converted into a wrapper class called integer. So basically that thing happens here. Okay, that's why it's called an instance variable. So then there is static int, right, j. So we don't have to create an object, right, of this variable. You can simply call it with the help of class name. Then the void method, inside that void method I'm declaring k, so it's a local variable. Okay, now quickly go ahead and see a little demo about this thing. Okay, just give me a minute. Yeah, so this variable that is declared here is an instance variable, right? If you have created a class here, right, right now if you don't understand how to create a class, it's okay, I will cover these things, okay, later. Now quickly go ahead and class. Okay, class a, okay, a, okay, that's done. Now I am declaring some variables inside this class, int a equal to 10. So basically what I'm doing, I'm creating in this a class there's a property called a. So now what I have to do to access this property, I have to create an object. So creating an object of this aa, right, let me call it obj, the object, right, equal to new aa, right? Then this is a constructor here. Okay, if you don't understand anything right now, it's just that I'm trying to cover it some in a specific flow. Okay, so now what I will be doing with the help of this object dot a, I will be changing its value. Okay, let me say it's 100. Okay, now if I try to access this, let me rename it because it will give me an error, right? Because this naming is not right. So this thing is gone. Now what I will be doing here, I will just go obj dot a. So now what we did here, we created an instance, right? This is called an instance of a class, right? Instance variable. Obj is an instance variable called object, right? This object, with the help of this object, I am accessing this a, right? And I'm changing its value. Right now, if I try to print it, what should be the value, right? It should be 100, right? Let's quickly see if it's 100. Okay, have we written it right? Yes, it is right. Okay, now give it some time. So 100, right? So this thing is called an instance. Now if somehow I declared it static, right? This is static int. Now do I have to create this object? No. Why? This belongs to a class, right? If I am writing this thing as static, I can simply go ahead and do this thing, right? A dot a is equal to 100. Okay, with the help of class name, I'm accessing this and simply just do this thing and just print this thing here. Okay, now if I try to run this thing, will this give me an error? Let's give it some time. No, because we are just using the static. Since it belongs to a class, we don't have to create an object, right? So directly with the help of this class name AA, we accessed its properties, right? Okay, now this is gone. Right now, if somehow I am creating another function here, okay, let's quickly go. If you don't understand this thing, but functions will be easy to understand. So how we create a function, basically give it an access modifier, right? This public thing. Then we created the function name, and first we have to write the return type is void, and then we create a function called fun. It doesn't have any arguments, and then I declared a variable called b here, okay, and b is equal to 0, right? Now if I'm trying to access it here, right, in this function, can I do that, right? Can I print simply b here? Can I do that, right? So by default values of this is 0, but that will be covering in the later part of this course, right? So if I quickly go ahead and try to run this thing, since the scope of this variable is within this frame, so it will give me an error. I cannot find the symbol b, right? Absolutely, right? Since the scope of this variable is local, right? I can't access it here. Okay, so these are some types of what do you mean by types of variables, right? So there is a instance variable, static variable, and local variable. Everything is covered, right? Now demo part is done. Now let's talk about operators. What do you mean by operators? Basically these operators will help us to create mathematical formulas, or all those things that are associated with addition, subtraction, shifts, relational operators, bitwise, logical operators, assignment, and ternary. Okay, all the things will be covered in this operator section. Okay, so now quickly see the first operator, that is unary operator. Basically it needs only one operand. What do you mean by operand? Basically if you're trying to say, let's say the two major operators that are of unary type are increment and decrement. Each one has two variations like postfix and prefix. Okay, what do you mean by this thing? Basically there is a pre-increment and decrement operation. So first let's see the demo, then the things will be easier for you. Okay, so now quickly remove this thing. Okay, we don't need this thing anymore. Let's make our code simple, as this thing is not required anymore. So this is the class, and then this public static void main, and then we will remove this thing as well. So now let's see what happens here. So here is a, and then is 10. Okay, now let's try to print it here. Okay, done. Now let me print it thrice. Okay, let me write this line thrice. Okay, done. And then it's here again, I will print it again, and here I will print it again. Okay, so now this a here will be, okay, it has been, just a minute. Okay, now let me do it this thing. What is this? This is a post increment. Okay, what is this thing? This is a pre increment, and then I will try to print it here again. So since this is a unary operator, so basically what happens here, it happens, actually this thing happens, a equal to a plus 1. This thing happens internally. So what, the double slash, with the help of this double slash I can comment this line. Basically it makes my code readable. This thing will be also covered, since we are talking in a certain flow, or we are executing our this course is having some kind of flow. So the things that I'm going to, maybe this time we won't be understanding what is happening with this double slash lines, right? Basically I'm doing using comments. Okay, this thing will also be covered. Okay, so now is the thing. So basically internally happens this thing, right? A equal to a plus 1. So the unary operator works in this way, that once so this is a post increment, right? First we will assign the value, and in the next line we will increment this thing. So the first line, here what will be the output, right? Here the output will be 10, because we are just printing it, right? Correct. Then this thing, what will be the value here? Basically it will be 10. Why 10? We are incrementing it, but it's a post increment. First, you assign the value, then you increment in the next line. So in the next line, the value of A will be 11, but there's a pre-increment associated with this A, right? So it will increment it first, then assign it. So it will increment it 12 and then assign this to this A. Okay, there will be 12. And what happens here? Here again, it will be 12, right? Since we are not doing anything, it will be 12. So the output should be 10, 10, 12, 12. Let's run it. You see, 10, 10, 12, 12. Okay, 10, 10, 12, 12. So this is increment, post increment and pre-increment. Okay, now I will just show you one more thing here. If I do a pre-decrement here, so it will decrement first this 12, then assign this value. So here the output should be 11, right? So it should be 10, 10, 12, 11. Okay. Give it some time. 10, 10, 12, 11. So these are the types of unary operators. Similarly, we can do post decrement. Okay. So first assign the value, then increment, right? Post increment. Okay, then prefix. So first increment and then assign. Decrement. Then this thing happens in the decrement as well. So decreasing by only one value. Okay, so these are the two variations that are associated with this unary operator. Okay, then we have this small demo on unary operator. Basically, this is also one of the way with which we can assign values to all the variables, like a equal to b equal to c equal to d equal to 5. So in all the 4 variables, value 5 will be assigned. Okay, so then we are doing increment, right? What type of increment is this? This is a post increment, right? So the a will be having only a value of 5 right here in this line. Then when we go in the next line, the a value will be 6. Then there is a pre-increment associated with b. So the value of b will be 6, right? All of these are assigned 5. So then there is a pre-decrement, right? And post-decrement, right? Post-decrement of c, then it will be still 5. Then in the next line, it will be 4. And then the pre-decrement of d, then what will be the value of d? 4. Okay, now the output will be as expected, 6644 of all the 4 variables. Okay, this is the thing. Okay, now let's continue to arithmetic operators. Basically addition, subtraction, division, multiplication, modulus, all these are arithmetic operators. Basically it comprises of all the arithmetic operations like addition, multiplication, division. Another additional operator is modulus, which gives you the remainder, right? If you're trying to divide 6 by 6, the remainder is 0. So the value will not be 1, which happens in case of division, but in case of modulus, the value will be 0, right? The remainder is 0 when we divide 6 by 6. So basically, then again we are declaring ABCD, then we are using addition, subtraction, multiplication, and the desired output is given in your screen. Okay, so this thing is easy. I don't want to show a demo on it, right? This is quite simpler. Okay, now quickly let's go on to the shift operators. Now the shift operators, what do you mean by these things? Basically, whenever we are using shift operators, the value whatever is inside and variable, right, it is converted into binary, then there happens a shift. Now there are two types of shift, like left shift and right shift. Left shift means shift the bits in its left direction for the specified value. So what do you mean by this thing? So basically, if you will observe this code, first we are declaring two variables a and b, then we are assigning a to both these variables, then we are using a left shift operator. Okay, now we are using a left shift operator twice. So what do you mean by this thing? So internally it will be converted into 32-bit a binary number, right? So then what happens, we are just shifting from left side. For example, let me just show you it on the screen. Okay, here. Okay, now what we are doing here is this 8 will be converted into binary. So what will be the binary of 8? 1 0 0 0, right? Hit this first 0 will be 1, then 2 4 8. So this is the binary number, right? If we basically there will be a series of zeros associated with as well, right? The 32-bit. So what happens, we are shifting this 1 twice to the left, right? So here it is, now it will be shifted to here, then here. Okay, so basically what happens here, we are shifting it twice to the left side. Okay, so now this one will be here. Okay, it shifts from this position to this. Now 1 2 4 8 16 32, the value will be changed, right? So now earlier what it used to be, just a minute, what happened, where was I? Yeah, here. Okay, what happened, we shifted it to the left side by 2 positions. Okay, so from 8 it went on to be 32, right? Now similarly, if we shift our bits to the right side, now we are just basically, what do you mean by this thing? Basically, when we are shifting, left shift is done, basically it means to multiply that many times. Okay, so 8 will be multiplied by 2 to the power of n. Basically here in the left shift, right, it will be, the n will be 2, so 2 raised by 2 is 4, 8 fours are 32, right? 8 multiplied by 4 equal to 32. So that's what's happening. Left shift increments the value. Similarly, right shift decrements the value, right? Similarly, 2 raised power n, right? N is 2. So this 8 will be divided by 4. What will be the output? 2. So when we are trying to right shift the operator, when we are trying to implement right shift, the value will be decremented. Okay, so what happens, we are shifting a bit to the right side, and by right side our value will be decreased because we have 1 2 4 8, right? The binary thing, right? When we're trying to, if you don't know how to convert decimal into binary, basically we are just doing that, we're just dividing it multiple times by 2. So that's how we get 1000, right, for 8. So now we are shifting it to the right side, now it will be 10, right, 2 times, and we are shifting it to the right, so the value of that will be 2. So this is the thing, right? The shift operators works in this way. Now let's quickly go ahead and see relational operators. Okay, it comprises of operators for comparison. Basically, whenever we are trying to do a comparison, right? If this thing is greater than this thing, then what happens, right? This thing greater than, less than, greater than or equal to, greater than or less than or equal to, right? For equality check, we have 2 operators, that is the assignment. For example, the equality, what do you mean by equality? If this thing is equal to this thing, or if this thing is not equal to. Okay, so for example, if a is equal to b, this means that we are checking if the value of a and b are same. So what do? We just use this thing. If a is equal to b, then give me true, else give me a false. Now let's see a demo of this. So the This is the class relational demo. Then we use three variables a, b, and c. Then a equal to 1, b equal to 2, c equal to 1. Now we have used some operators here, right? The less than, the greater than, less than or equal to, greater than or equal to, then not equal to, then equal to. Okay, can you see the output is true, false? Basically it's a boolean, right? So basically, let's just show me the demo, then the things will be much clearer. Okay, so this thing will be removed. Okay, we don't need this thing anymore. Now let's quickly define here some other variable. Int b equal to 20. So now if I just wrote this thing, if a is greater than b, is a greater than b? No, the output will be returned, the return value will be false, right? A is not greater than b. So what will be our output for this statement? If I just remove this thing and I remove the comment, though it won't affect our program, but still. Now we just, when we run our program, right, the output should be false, right? A is not greater than b, right? The output is false, right? So if I just wrote here 10, is a equal to b? Yes, it is. Output should be true, right? So the assignment operator is the equality operator, that the double equal to sign has been written. The output should be true because I have changed the value of a and b. That both of them are 10, right? So the output should be true. Just give it some time. True, right? So this is the thing. And if I just wrote this thing, if a is not equal to b, then the output should be a is equal to b, right? This is just the opposite of equality operator which we used earlier, right? This thing works only when it's not true, but right now it's true, so the value should be false, right? So these are some relational operators. Okay, now let's quickly go ahead and check all the things, right? So greater than, less than, and just implement these things. These are really simple things. Okay, so the relational operators are done. Now the most important, with which we can solve a lot of problems, lot of computer programming problems are solved with the help of these bitwise operators. It computes basically by going bit by bit. So when we are talking about bit by bit, basically when we are using these bitwise operators, basically if a number stores 8, basically this is not treated as 8, it's treated as a binary 8, binary of 8. What is binary of 8? 1 0 0 0, right? 1 2 4 8, right? 1 0 0 0. 3 times 0 is the binary of 8. So basically we will go bit by bit. Both sides is checked irrespective of what first expression computes to. For example, what do you mean by this thing? There are 4 major operators, right? Let's talk about this thing, then the upper thing will be clear. Okay, so there are 4 bitwise operators: and, or, XOR, and not. So this thing, what and does, it only gives us true if both the bits are 1, else it will return for 0, right? So for example, if I'm doing by 1 and 1, right? This and, the bitwise and, so the output should be 1. If I'm doing 1 and 0, the output should be 0. And in OR, if any of the bits is 1, the output should be 1. And XOR works a bit differently. XOR, this XOR bitwise operator, if both the bits are different, it gives 1, else it will give 0. For example, if 0 XOR 0, it gives 1. 1 XOR 1, it gives 1. If any of the bits are different, that means 1 and 0, 0 and 1, then the output should be 0. And bitwise not will just it will just complement the thing, right? What do you mean by this? That if you are having 1, it will complement it to 0, right? If you are having 0, it will just change it to 1. Okay, 0 to 1, 1 to 0. This is the bitwise operator. Okay, what do we let's see the demo. Okay, so we are basically having 2 variables, 1 and 2. both of them are having some values, right? 1 and 2. When we are trying to do AND of 1 and 2, what should be the value? So basically this thing will not be clear if I won't give an example. Okay, so let's take two simple values. Okay, these are the two values. Okay, so basically internally it will be it will be basically something lot of zeros and 32 zeros. Then the last bit will be I'm so sorry, so the last will be a bit will be 1. Okay, and similarly this will be a lot of zeros, basically 32 zeros, and then the last two bits will be 1 and 0. Okay, so now we are doing AND. So you see, AND only gives us the output as 1 when both of the bits are 1, right? So here 1 and 0 will give us an output of 0, right? And 0 and 1 will give us an output of 0. So that's why when I will do this thing, what A and B, what should be the value of this thing? It should be 0. So that's what AND does. It will check if both the bits are in both of these variables A and B. If both the bits are 1, only it will give the output 1 then. So now that's not the case when we talk about bitwise OR. What will be the output when we talk about bitwise OR? Right? This is the OR operator, right? So this will give 1 and this will give 1. Then it will be again converted to decimal form. So there will be a lot of zeros, 30 zeros. Then the last two digits will be 1 and 1. Then that 1 and 1 means that the value should be 3. So that's what we get. If we run it, we will get an answer of 3. Right? We got the output as 3 here. Now, if we wrote a negation sign here, then the output will be, all the zeros will be converted into ones. That won't make any sense because we'll get a huge number, and then we have to just, to say that we have to then just, if we are talking about some big number, right, we are all converting this thing to zeros, it will be converted to 1, 1, 1, 1, 1, and it will give us a huge number, right? So that won't make any sense using negation operation. That means not operator. Rather, if we try to implement the XOR operator, there's a caret sign, then there's B. Okay, now what we are doing, A XOR B. So the output should be, output is only, so basically the output is only 1, or the output is true only when both the bits are same. So herein all the bits are same except the last two, so the output will be there, right? Let's just run this thing. Give it some time. It's taking time. You see, the output is 3 when we try to do XOR operator. Okay, you see, when we trying to do XOR of both the bits, right, the XOR operator which returns 1 if both the bits are different, right? So there is 0 and 1 at the end and 1 and 0 at the end, right? So it was converted to a lot of zeros, 30 zeros, then at the end it was 1 1, so it will be converted to decimal. The decimal of 1 1 is 3. Okay, else it will be 0. So this is all about bitwise operators. This is the demo, right? We have covered this thing. Now let's talk about logical operators. So logical operators are used for conditions, right? Comparisons, basically checks for the validity of them. Okay, what do you mean by this thing? Basically, if this thing is true and this thing is also true, only then return me some value. Okay, or only then print this is true. Okay, so how these logical operators work, basically, if you're trying to see if the age is greater than 30 and if the age is less than 60, only then we can depict that he can go to watch a movie. Okay, let's just increment the age. If the age is greater than 18 and less than 60, only then you can watch a movie. So how would he write it? If age is greater than 18 and this logical and, that double ampersand sign, right, is greater than this thing and it's less than 60, then you can go and watch a movie, right? So these things helps there when we are doing some comparisons, right? They are also used in loops as part of the termination conditions, like in if I have reached this condition, then please go out of the loop. Okay, this can be used there. There are three operators, right? And, or, and logical not. Basically logical not will return to true when the condition evaluates to false, right? So if I'm saying that if age is not equal to 60, right, and the age is 60, so basically it evaluates to true, right? Returns true. It returns, right now its value is true, right? So but it returns false. Okay, so if the value is true when the condition evaluates, it's false. So if age is equal to 60, right now it is 60, so it will return as a false value. But if age is 20 and I'm doing a comparison on 60, then it will return a true value. Okay, so let's see the demo. So basically I'm using again a equal to 1 and b equal to 2. Then I'm checking if a is equal to 1, right? It is 1. So that thing is clear, right? That thing gives us true output, right? The first line, that the first SOP line, right? Thing will give us true, right? As we all know, this will give us true. If this thing is true, only then we will check the second condition. Right now it is true, so we will go on to the next condition. B is equal to 1. No, it is true, so it will give us a false, right? The output of first line will be false. Okay, so there is one important thing when we are dealing with these logical operators, right? If the first condition is false, then the AND will not go to the next line. But in OR, if the first condition is false, then it will still go on to the next line to check if that thing is true or not. So basically in logical AND, that is the double ampersand sign, both conditions return must be true, only then the result will be true. But in logical OR, it's not the case. If this thing is false and the other thing is true, it will still give us a true result, right? In case of this thing, right, if a is equal to b, right, yes, a is equal to b and b is not equal to 1, that will give us false. But true and false will return a value of true, right? That's the output. Now you see, now I'm using the not operator here, right? The logical not. So it checks if a is equal to 1. Yes, it is. It will return a true value, but then I'm negating it, right? So true will be negated to false. So that's why I get an output of false. Okay, this is how logical operators work. So let's quickly see a little demo about it. So let's see, a and b are given here. Now let's see. Let's do one thing. Let's check if a is greater than or equal to 1. Yes, it is. It will give us a true, right? Then I will do an and b is equal to let's say b is equal to 0. What should be the output? The output should be false, right? Because the first condition is true. Yes, it is equal to 1, not greater than, but it is equal to 1. But b is not equal to 0, so that will give us a false, right? And should have both the conditions from this side and that side should be true. But in this case, one is true and another is false, so the output is false, right? So now if I just change this condition here to OR, right, so the output will be true because one condition is true. Give it some time. Okay, output is true. Okay, so this is how logical operators work. Now the assignment operator and ternary operator. Basically assignment operator is used to check the assignment thing, that double equal to sign, right? So now the single equal to sign, the assignment operator is usually used to assign the right hand side value to the left hand side. Basically if I'm using what we were using until this point, that a equal to 10, basically we are assigning 10 to that variable a. So this is what the operator that we're using, equal to sign, is the assignment operator, right? Now the ternary operator. Basically ternary operator, you won't understand it right now because we haven't covered the if thing, right? I'll still give you an idea about it. Okay, so basically it's an alternative for if else. Condition is placed before this question mark sign. So if you can see in this printf, if you can see in this sop line, wherein we are trying to print, we are checking a equal to 1. Is a equal to 1? Yes. Then the expression which is supposed to, if the expression is true, then the first part of the ternary operator will be executed. Okay, so this thing will be executed. If it's not, then this thing will be executed, the other thing after the semicolon. Okay, just quickly give me and let me give you a demo about this expression. You won't understand it right now thoroughly, but still the things will be clear. Now I'm checking if a equal to 1, right? Then I'm writing a question mark. Okay, this is the condition thing. Then if something is, then if I write here true, or if I say then assign a equal to 1, so else assign a equal to 2. So this is the thing. And the ternary operator will work in such a fashion that the first thing is the condition. Then if the condition is true, then a equal to 1 will be executed, else a equal to 2 will be executed. You will not understand it right now, but this is the syntax, and we are not going to use this any I mean to say, when you will be coding, you are not going to use this thing as much as you will be using if else. So it's just an optional way, or the code will be minimized in this with the help of this ternary operator, but we are not going to use this thing. Okay, now let's quickly go ahead and check the other things. Okay, this is the syntax and this is the demo. Okay,
Now let's talk about data types. So there are different types of data that one deals in real life. Okay, so to process them, we need different types of containers or data types as storage. Okay, now in Java, there are 8 primitive data types. That means they are present to us by default. Okay, for example, byte is one such data type. The size of byte is 1 byte. Okay, by default, it holds a value 0. Similarly, we have int, which is of size 4. By default, it holds 0. Short, 2 bytes, default value 0. Long, 8 bytes, default value 0. Char, 2 bytes, default value this Unicode, that is /u and 4 zeros. Boolean, size 1 bit, it can be either true or false. Float, 4 bytes, by default value 0.0. Okay, double, 8 bytes, by default value 0.0. So if you observe these primitive data types, int, short and long come under single category, and float and double come under one category. Okay, so these are all 8 these are the only data types, that primitive data types we have. So there are some non-primitive data types as well, like arrays, classes, right, such as string, right, any class we define. Those are all non-primitive data types. Okay, so now quickly go ahead and try to implement these things, these data types. Okay, so before we start, now let's check some conditional statements. That is, if this thing is correct, then do this thing. If this is not correct, then do this thing. It consists of 2 keywords, right? There are 2 keywords present in here, right? If and else. Again, these keywords, we can't name our variables, as in if you think that you might name your variable like if, no you can't. Okay, else, no you can't. These are keywords. This is a way where there are 2 paths possible depending upon a condition. If you see the diagram, there's a conditional expression, right? If the conditional expression is false, then go to the else code. If the conditional expression is true, then go to the if code. Okay, if condition manipulates to true, then it gets executed. If the condition in the conditional expression is true, then it gets executed. It sends the code to the next statement, that is after this if condition, right? Then if it's not, then it goes to the else part. There can be multiple ifs, right? For example, if, then else if, then else if, then else if, then else. So you can have possible more than 2 ways, right? So if you say that, for example, there are 4 possible ways, that if your condition is not true, you can have four possible ways, right? So what are the four possible ways? How can you show it, right? If this is true, then do this. Else if, check this condition. Else if, check this condition. If we are done with three conditions, right, then it goes to the else part. Also, it can be nested, right? Now let's see the demo of else if, or if else rather. So herein we have two variables, right? Two data members are there, right? So what are the variables? A and B. So then we checked if A plus B is equal to this double equal to sign means that we are checking equality condition. So if left hand side and the right hand side are equal, then print true. The output is shown as true, right? So if it's not, then it goes to the else statement and prints out false. Let's quickly go ahead and implement this. Okay, so for example, just a minute. Yeah, so for example, if we have a variable name, for example A, let's make it right now, let's put it A. Okay, then we have a variable another, that is B equal to 1. So now let's check condition. If A is equal to B, right, these are equal, right? We will then we open this block, this curly braces. This is the block of this if. Okay, cool. So then what we will write println what? Let's suppose that we just printed true. Now else part, else, let's copy this line again, the block of else. Let's copy this line and print it here. Okay, now what should be the output? Let's make it false. Okay, what should be the output? As we all know, the output should be true. Let's check that out, give it some time. Cool, the output is true. Now there's one shorter way or a trick that you can implement. So if I remove these curly braces, is there a way, or will my output change? No, absolutely not, because what compiler predicts or depicts from this thing, that this statement, if there is no curly braces given, this is associated with this if. Okay, anything that I write in between will be a individual statement. For example, if I declared C here, right, let's remove for now. Let's check if this thing works. Okay, now what should be the output? Still it should be true, right? Give it some time. Cool. Now if I write this thing here, now what this the compiler thing, that this is the thing which is associated with this if, then this is another variable that we defined. Now here is else part, right? So the compiler think that this is a else without if, so it will give you an error. Let's quickly go ahead and check that out, that it will say it's else without if, right? Else without if. Cool. So if you haven't written anything here, then it will work fine, as we saw this thing earlier, right? So this is the if and else block. Okay, cool. Now let's go back to our demo, right? So this is else, if else. Now the conditional statements. Basically, if you have multiple if, else if, so you are the condition, after the conditional expression, you have more than 5, 6, 7, 8 paths. So it doesn't make sense to write else if 8 times. For that we have switch. It's an elegant way to replace multiple else if statements. Okay, so you have 8 paths. Rather than going for else if, you should go for a switch case. Okay, so switch is written in this way. This expression is written here in the brackets, right? Switch brackets, that's the condition, and on that condition, those one of these cases will be executed. Okay, and it's having default case. If none of the cases match, then the default case will be executing. Here, depending upon the answer evaluated by the condition, case code gets executed, as I told you earlier. Every case must be followed by a break unless it is required, not to as per logic. What does this mean? For example, if you somehow missed to write a break statement, right? So what the compiler thinks that you don't want to break, so it will execute the next statement until it finds the break. If you haven't written break until default, all the cases will be executed. Okay. So otherwise, all the cases will start executing from the matched case till either break is encountered or all the cases are exhausted. That's what I told you, right? So if you haven't written a break, so all the cases will be executed until the default case, or if you haven't written default case, it's optional. Okay. So if you haven't written a default case, all the statements, all the cases will be executed. Now what should be this expression? This can be an integer, character, or a string in Java, right? Cool. This is the conditional statement switch. Now let's see the demo how to write. For example, this is the code that is written here, string day equal to sun, right? Now switch day, this day has been passed. What will be the value in day? Sun. Will the case first will be executed? No. Second case? No. Third case? No. The fourth case, that is, it matches with the sun, and we will print out the output, today is Sunday. Then we will break from this condition, right? So the default case will not be executed. Okay. When will be the default case executed? If none of these cases match. Cool. Done with this switch case. Okay. Now let's talk about loops. So basically there are two major loops, right, that we encounter in our day-to-day programming, that is while loop and for loop. We also have do while loop. We will check that thing also in this session, but the main loops are while loop and for loop. It's best to use when you know the specified expression depending on whose value the code should execute. What do you mean by this thing? We must know what is the expression that we want to execute it on. So for example, let's see the demo here. We have int I equal to 0. Then I will execute 5 times and will print the output, right? Okay. So the output will be printed 0, 1, 2, 3, 4 times, right? Actually 5 times if we include the 0 as well. So while, then we write the expression, then we will execute the statements, and then the last statement, or you can increment it anywhere between this loop, then the value will be incremented, the condition will be checked again, right? Expression is used to dictate the condition who is responsible for the loop continuation. Okay. Now if this thing is not understood, let me do some demo on it. Okay. So for example, this thing, let's remove all this thing, we don't need this anymore. Now we will define a variable a, and now what we will do, I told you please write me a program that prints numbers from 1 to 5. Okay, from 1 to 5. Okay, so I wrote while, because I know the condition, right? While I is less than 6. You can write less than 6, or you can write less than or equal to 5. Okay, whatever suits you. Then what we will write here, println, right? We'll do println, then we will print this value I. Okay, let's rename this variable as I. Okay, cool. Now we have printed this. Now what we will do, we'll increment our I. So we'll do I plus plus, right? This means I equal to I plus 1. Okay, cool. This is how we write comments. We will come to this thing as well. Okay, cool. So now what will be the output? It will be 1, 2, 3, 4 and 5. Cool. Let's see. Give it some time. Okay. You see 1, 2, 3, 4, 5. So this is the while loop. Now let's go back. So while loop done. Now for loop. Basically, let me show you a demo first, then the things will be much clearer. So if you observe this thing, that I have written the initialization of variable here, then I'm incrementing here, then the condition is checked here, right? So is there a way that I can do all these steps in a single line? Yes, for loop comes into picture. You see, if I write int, let's suppose j equal to 0, or let's do the same thing again, equal to 1, then I check the condition. If I is less than or equal to 5, then I not, and I is not, it's j, right? So then j plus plus. You see, we are able to do same thing but in a single line, rather than going here, then condition here, then the updation here. There's a simpler way, right, for doing this. That is J. So now what should be the output for the first loop? That is this while loop. The output will be 1 2 3 4 5, and for the next string again it will be 1 2 3 4 5. Okay, let's run this thing, give it some time. You see how easy is this loop, right? Everything is done in a single line. If you see, this is 1 2 3 4 for the upper loop, that's the while loop, then this 1 2 3 4 5 for the for loop. Now let's go back to our problem. Now for loop, it's the best to use. Similarly, if you know how many times your code will execute, you can use for loop. For example, now that for, in the first part we will do initialization, in the second the termination, then the third part is the updation, right? Initialization, in which we initialized our variable, right, which is being used for the iteration. Then the termination, that is the that comprises of conditions which will determine how many times we will iterate in a loop, right? For example, we have to print 5 variables, right? 5 times we have to print 1 2 3 4 5. So we know that we have to write the condition here which will execute only 5 times. Then the updation part, right, wherein we increment our variable by 1. Similarly, if you want to increment your variable by 2, you can use that thing also. That can be done also. For example, let me show you. So now what you want this variable to increment by 2. So what you will write, j equal to j plus 2. Okay, now what will happen? 1, then 3, then 5. Let's run this code. The first thing will be that 1 2 3 4 5, and then there will be 1 3 and 5. You see, 1 3 and 5. Cool. So you can do this thing as well. So for loops, this is the demo which I have already explained to you, right? This is the for loop. Then we print the current value of I, then all the values of the output is shown in the screen, right? 0 1 2 3 4. Done. Cool. Now the do while. This is the least used loop in our day-to-day programming, right? So why is it least used? Because this loop will execute anyway one time. What do you mean by this thing? So what do you mean by do? First do the thing, then check the condition. Even if the condition is not right, for example, if I told you to print a number only if its value is greater than 0. So if you see in this I equal to 0, I will be equal to 0. Now this loop shouldn't work, right? But it will still execute it single time. Okay, so it's best to use when you know that at least the code must execute once, irrespective of the condition, because the condition is checked at the last. Okay, so the syntax is do, then the brackets, these curly braces, then the while, and the expression. Okay, the expression part is at the end. So do first, then check. Okay, expression is used to dedicate the condition, just like in the other loops as well, right? We saw those things. So this is the demo of this thing, right? Int I is equal to 0. Then we printed the values 0 1 2 3 4, and the condition is checked at the last. Okay, this is our do while loop. Now the branching statements. For example, if I told you I don't want you to print all the numbers from 1 to 5. If you encountered 3, then break out of the loop. So how would you do it? Therein we have break. For example, if you see the demo here, right down on the screen, right? You see I have written if I is equal to 3, break. So what should be the output? 0 1 2, then it breaks out of the loop. Okay, it can be used in loops. For example, your while loop, your do while, and your for loops. Okay, cool. So this is the keyword basically that terminates the current loop and moves the execution out of the loop. So if you see, it breaks you out of the loop, not out of the program. Okay, there are some branching statements which will return the condition, return the execution to the function that's calling it. Okay, this does not do this thing. Okay, it's still in the main function, it just breaks you out of the loop, and then you are out of the loop. That's why I have written to show you guys that the condition moves out of the loop and the statement out of the loop is printed on your screen. Okay, now let's check this thing out. Okay, let me show you the demo quickly. So I will first print the statement. Then I told you if this j is equal to 3, right, then don't go ahead, just break out of this loop. So once we are out of this loop, then let me just write a println so that we will know that we are out of the loop. Let's say hi, this thing, that doesn't make sense. Let me show you hello. Okay, cool. So what should be the output? The first, that 1 2 3 4 will be printed, right? That is the thing. And then 1 will be printed, then it encounters 3, it prints first 3. So I'm writing the print statement ahead of the condition, right? So it prints 3, then it breaks out of it, it doesn't go to the 5, right? Then it prints hello. So that's why 1 2 3 4 5, 1 3 and hello. So this is one kind of a branching statement. So break. Now let's see the another branching statement, that is continue. It doesn't like what we saw in break. It doesn't make your code go out of the loop. It just skips rest of the part after the condition is met, then goes to the condition again. Let me show you. Okay, so here's the thing. Now let me just let me just change it a little bit so that you guys might notice the changes that I'm doing. So I will print it here, and then I will print it here again, and then I will just write continue here. Okay, let's remove this part which is written above it. We don't need this thing. Then let's write hello here. Now what will happen? So let's try to debug this program. Okay, so j is 1, it will be printed first time. Condition is not checked because j is 1, then 1 will be printed again. So then comes 2, then 2 will be printed twice. Then comes 3 will be printed single time. The next time it will just skip the lines that are below this continue keyword. Then the condition goes back to that thing, right? The expression part wherein we check the condition, this thing which I highlighted. And let's also make this plus that we are incrementing only it by 1. Okay, so what should be the output? 1 1 2 2 3 only once, then 4 4 and 5 5, then it prints hello. So let's check this thing. You see the continue, it doesn't break you out of the loop, right? You see the difference that it is having with the break statement, right? You see 1 1 2 2 3 only once, then 4 4 5 5, then hello. Okay, cool. Now let's read about it. So it's a keyword that basically terminates the current iteration and moves the execution to the updated part. So basically it happens that once it encounters, then it goes to the updation part of the loop, that is I++ that we did, or J++ in our case. Then it checks the condition and continues again. Okay, this is the continue branching statement. Now let's see the demo. We have already seen the demo. This is just for your remembrance, for you to understand the code if you somehow skipped something. So this is the demo of continue. Okay, so herein we also printed the statement, right? Continue, we are skipping 3, it goes then to 2, then 4, right? You see, cool. Now let's move ahead and check the last branching statement, that is return. So basically return is used to return the execution pointer will be returned to the function that's calling it. For example, if in the main I called some function, right? Then in that function I wrote return. So the execution will return after that function call. Okay, let me show you what happens. Okay, let's check the demo first and then we will move to this part. Okay, so now whatever I have written this thing, now I will write this thing, return. What will happen? What do you think, guys? What will happen? So let's run this thing, then try to debug it. Okay, give it some time. You see what happened? 1 1 2 2 3, that's it. So what is happening? We know how 1 1 came and how 2 2 came. Then 3 will be printed here, right? In this condition 3 will be printed, right? Cool. So in this then it encountered a condition wherein it checked that j is equal to 3. Yes, j is equal to 3. Return. This statement will not be executed. It won't go into this updation part. Now it's not breaking it out of the loop as well, just like break. It's not working like break, it's not working like continue, rather it's returning it. So you see, hello is not printed as well, right? So it returns the condition after this, I mean to say after this function or method, rather to be specific, it's a method. So it returns the function pointer, right? So it will return from this method. Okay, you see the difference it's having as compared to break and continue, right? This is the difference. This is the main difference, right? So we are returning our program execution, right? It returns from the block of the code. If it's inside a function, it will exit from it, right? That's what happened. It exited from the function, right? You see, it exits from the program. If it's in the main, it exits from the program. Okay, that's what happened. We didn't get the message out of the loop, or in our case that we have printed hello was not printed. It was in the main, right? So it exited from this method. Okay, cool. So we are done with these all branching statements. Cool. Now let's talk about comments. Basically, comments is the most beautiful way to show someone that this is the thing that you're doing. It will not render on your screen, or it will not print anything. It will never be displayed on your screen. It's just for your own purpose. That is, it serves as a thing to make your code more readable, make it more, I mean to say, better coding practices. This using comments. Comments are used to give brief description of what the logic is behind your code. So if you're doing this, for example, in the updation part, we did j is equal to j plus 2, right? So that was the thing. We are incrementing it twice, right? If someone or some person in your company wants to know why you are doing this, so you will just write a comment. Okay, so they are ignored by the compiler at the time of execution. It will be ignored by the compiler. In Java, there are single line comments and multiple line comments. So for writing a single line comment, you just have to do /, and for multiple line or multi-line comments, you just have to use / asterisk sign or the star sign, then star sign, and then the slash. Everything written in between these two lines, everything written in between these two, I mean to say these two identifiers, right? The slash and star, and this star and slash will be ignored by the compiler. Okay, cool. This is all about comments. Now let's talk about class. A class is a blueprint of real life entity. What do you mean by this? Basically, a class consists of data and methods, right? So now if we want to access those data members and methods, we need to implement something, right? Basically, we need to create an object of that class, basically, right? So it is an implementation of encapsulation, which is one of the pillars of object-oriented programming. So earlier when I told you that Java is a high-level language, that is an object-oriented, also high-level object-oriented language, right? When we talked about in the starting of the session, right? Java is a high-level object-oriented language. What do you mean by that object-oriented? Now we are going to cover all those things. Basically, encapsulation is one of the object-oriented programming pillars. Okay, keyword class is used to declare the class, right? We have seen it earlier also, right? As per the naming convention, class name follows the first letter of every word should be in uppercase, right? When we talked about a simple hello world program wherein we wrote my first code, M was capital in my, first was F was capital in first, and C was capital in code, right? This is the naming convention, how to declare or how to write a name of the class. Okay, in Java, all the code must be in some class. Okay, everything that we write should be in a class. Single document can have multiple classes, but only one public class. What do you mean by this thing? In a single document, we can have multiple classes, right? There are different classes, class A, class B, class C, but there will be only one class which will be public. Okay, right? And in that public class, we will be having our main method, right? From which we can execute our code and implement all the classes in that class by extending it or by implementing it. We will see that thing. Okay, so a class is a blueprint, right? So basically it is like an if we talk about architecture, right, he gives you an blueprint, right? This is where going to be your lobby, this is where going to be your bedroom, this is the kitchen, this is the uh, bathrooms and all those things, right? This is the class. Basically that blueprint is a class, and when we implement it, then it becomes your house, right? That now when we are trying to implement this class, we need objects. Now let's first see how to write a class. So here's a class container, right, in which we have data members, methods, and some other methods, right? Basically there are three methods in which we set a color, we set weight, we set price, and then in the print we try to print all those things, right? There are few data members and now few methods. Okay, so this is the class container, right? This is the blueprint, right? Now if we want to access any data member or methods in this class, we need an object. So object, right, it basically is a physical entity. Earlier it was just a thing there, right? A class is there, but how we can implement, how we can use that class, anything that is present in it, we can implement it with the help of this physical entity called object. It is classes instance, right? It is classes, right? We talked about instance variables, static variables, local variables. In that particular thing, this is the object, right? This object acts as a class instance, right? Instance variable, right? New keyword is used to create objects and allocate memory in heap. Okay, whenever we use new, we are creating objects and we are allocating a memory in heap. Basically we can create a or allocate a memory basically in two ways, right? A stack memory is there and a heap memory is there. Basically when we use new keyword, we are using a heap memory. When we create an object, it calls a constructor of a class, right? We have seen this container, the first line in the example, the first word that is written container, basically it's a class. Now C1 is that object, right? And new we are allocating memory on the heap. Okay, now this container within and then the brackets, this is a constructor. Now let's see what a constructor is. We are calling here along with the new, we are calling a constructor. Basically every time when we are creating an object, a constructor is called by itself. Okay, now constructor is a special method that is used to allocate memory and initialize objects, basically, right? So it doesn't have a return type. We will see a example wherein we see a constructor doesn't have a return type. Its name is same as of its class name, right? Whatever is the name of the class is the name of the constructor without any return type. Compiler implicitly provides a default constructor to allocate memory if no constructor is called explicitly, right? So if we haven't defined any constructor, right, a default constructor is provided to us by a compiler implicitly, okay, automatically. Constructors having parameters are called, right, what are they called? They are called parameterized constructors. Okay, when new is encountered, it calls the constructor, right? We have seen in this example, right? Whenever we use new keyword, along with this we are using a constructor, so the constructor is called. Parameters passed at the time of creation of the objects determines which constructor should be called. For example, if in a program there are multiple constructors, right? We have defined a program in such a way, so how to differentiate which constructor should have been called or which constructor is to be called? It depends on the parameters, right? If we are passing int type of data, then this constructor will be called. If int type of data is passed, then this constructor will be called, and so on. Okay, now let's see an example wherein we use class, constructor, and the object is created. Okay, this is the example, right? In this example we have created a class called container in which we have three data members, right? Weight, which is of type int, color, which is of type string, price, which is of type double. Okay, now we have defined a parameterized constructor wherein it is having three arguments, right? Int, string, and double. and wherein we set data members with the help of these parameters. Okay, then we print I am a parameterized constructor. Okay, then there is a default constructor, right, which we have defined. So wherein there is no argument to this constructor, right, the container constructor, there are no arguments in it. So it says I am a default constructor. Now there is also a function or the method they defined to print all of these data members, right? Now let's try to implement all those things, right? The class, the object, and the constructor. So this is the class that we have written here, right? The container class, which contains 3 data members. What are they? Weight, color, and price, along with its data type, right? The weight is integer type, string type of color, right? The color is of string type. Double is the price, right? And then we have 2 constructors. One is parameterized and one is default constructor. In the parameterized constructor, we have 3 arguments, right? Integer and string and double, right? So these are the 3 arguments. Then we assign these arguments some value with the help of data members, right? Data members are assigned weight is assigned W, then color C, price P, right? Then we have printed a statement called I am a parameterized constructor. So in the default constructor, we have written system.out.print and I am a default constructor. Also, we have another method right here wherein we try to print all these data members. Okay, now we have another class called constructor demo, right? In that we have a public static void main method, right? And in that class we are trying to create 2 objects, one which calls the default constructor and the other calls the parameterized constructor. So after that, once we are done with this, then we are calling C1. Then with the help of this object 1, we are calling the print method, and with the help of object 2, we are calling the print method again. So you see, when we are creating an object with the help of default constructor, the value of all the data members is what is the default value of those data types, right? Integer we have 0, string we have null, and for double we have 0.0, right? These are the things, right, when we call the constructor in which we haven't defined any arguments, right? But for the object which calls the constructor in which we have defined and data members are assigned accordingly, right? In that object, the values are the values which we passed, right? 10, red, 567.85. So you see, this is the program that implements all the classes, objects, and the constructors. Okay, so now quickly let's go ahead and do a little bit of coding. Okay, so what we will do here, we will just first quickly go ahead and create a class. Class name is the keyword, then we give a class name, right? A, B, C. This is the class name, right? Oh, give an abstract, okay, C, right? Then we create a class, and in that class we create a data member, int roll number, okay, equal to nothing. Okay, then we have a constructor here, what, ABC, though the naming is not right, let's make the naming convention. Okay, and this is the A, and in that constructor we haven't defined any arguments, right? So in this constructor, what we will do, we will just write println. Okay, just give me a minute here, and in this I will write constructor, right? This is done. And when I'm creating an object for this class, right, A, B, C, right, in that I will create OB equal to new, then the default constructor has been called here, right? Now let's try to run this program. That's it. Now what should be the output? The output should be constructor, right? Let's see. Okay, now in the same constructor, if we try to define a int r, and in that what we will do, we will call this p constructor, and then what we will do, we will just assign role equal to R. Also, what we will do, we will also create a default constructor. Let's see what happens if we do this. In that, we will do this statement again. Okay, Control Z. Okay, this statement again, and we will paste it here, and we write here nothing but the constructor. So now when we call this constructor, and herein we pass 10. Okay, that's it. Let's see what happens. Do we get any error message or not? Let's check it out. You see, this constructor was never called. Why? Because we are calling a constructor with the help of this, wherein we have passed the arguments. Now in the same example, if we do something O equal to new, and in that new we will call ABC without default, without any parameters. Okay, then what happens? First there will be an output of constructor, right? Then P constructor, right? As we have expected, right? So this is the thing. Now let's go ahead and back to our code, right? So now let's talk about super and this keyword. These are the most important keywords when we are talking about object-oriented programming language. Okay, when we're talking about OOPS, these two words are most important. So what is super? Super is generally associated with a parent class. What do you mean by parent class? We will, after this slide, we will cover inheritance. We will talk about these things extensively, right? And we will implement also these things, right? So right for now, just listen to me very carefully. Okay, super is generally associated with parent class. Now let's compare it with this. This is generally associated with current class, right? That deals with, super deals with parent class, this deals with current class. I'm trying to build here some intuition, what is super and what is this. So listen to me carefully. Okay, so when we use extend keyword whenever we use during inheritance, that will establish a child parent relationship. Okay, whenever we use extends keyword, right, that establish a parent child relationship. We will see what is this relationship. Okay, you can call parents methods, that is, you are in child and you want to call parents methods, data members and constructors using super. Okay, now when this is used for calling same things, right? Class methods, data members, constructors using this. You see the intuition behind keeping these things first and then talking about inheritance, so that you have a clear picture in your mind what super and this does. Super parent relates to parent class, this relates to current class. They both are doing same things. That's why I have written this slide before going into the inheritance. Now both of these should be the first line of the code. Okay, if you want to call your parent constructor, right, super has to be the first line of the code. Similarly, now if you want to call the constructor of the same class, that is, you are in the child class and you want to call the constructor therein it has to be the first line of the code. I know this won't make any sense because you don't know inheritance until this point. Now let's quickly go ahead on inheritance. So basically it's the most important pillar of OOPS. We have covered the first pillar, that is encapsulation with the help of classes, right? Now this is the second pillar. Facilitates reusability. Why we do inheritance? To facilitate reusability of code. What do you mean by this thing? Basically, when we are inheriting something, that means we are reusing the code that is in the parent class. So you see why we do inheritance. Child can also implement additional data members and methods on its own, right? It makes sense, right? If you are inheriting something from the parent class, in the child class you can do some extra stuff, right? Cool. There is a relationship. It's very important. There are two types of relation, has a and is a. So this is a relationship between child and parent. For example, we will cover this thing in the next slide. So let's leave the example. We will implement it. For now, let's remove let's not go into the example. I will show you the demo, and after that things will be much easier. Okay, Java does not support multiple inheritance. Why? I have already told you, due to its ambiguity, right? It may cause, we know, or if you don't know about this diamond problem, basically that's the thing. Multiple inheritance, when we do multiple inheritance, basically we have a parent class, then it has two child classes, both are inheriting from this parent class. Then there is another child class that inherits from both these childs, that is of the parent class. Okay, so there it becomes a diamond kind of a structure. So there is ambiguity. So that's why Java doesn't support multiple inheritance. Okay, cool. So how can we implement multiple inheritance? Through interfaces. We will talk about them as well in the coming slides. Okay, now let's quickly go into the demo. So before we go into this demo, let me quickly show you how to implement all these things. Now let's check the demo. Okay, so herein we have a class hostel. Okay, in this class hostel we have two data members, that is address and name. Then we have a constructor in which we are passing address and name. Those are set, right? Done. Then we have another constructor name. We have parameters, two parameters in that constructor. Then we have a single parameterized constructor, right? There is name, then we set the name. Okay, cool. Then we have a method in it, right? Address, wherein we print the address. Then there's a child, room, right? A room class is there, which is a child which inherits or extends hostel, right? It's the child class and that's the parent class hostel. Okay, in that we have two data members, right? Number and name. In that room we also have a constructor which accepts three arguments. Okay, then we have a print method, right, wherein we print all the details, name, address and number, room number. And then we have a main method, right, the class main, in which we have a main method wherein we just create an object of this child class, right? The room is the child class. We create an object and we pass three arguments, and then we call print room details, then the output on the screen. Now let's quickly go and check the demo. Okay, cool. Now let's start. First we must have a class, so let's quickly create a class. Let's call it demo. Okay, keeping naming convention in your mind. Okay, now it has an integer data member which is I. Let's be more specific. Let's say name. No, name can't be. Roll number. Let's see. Okay, now let's create a constructor for this. Okay, let's create a demo. This is how we create a constructor, right? It has to be same as the class name, right? Done. In this demo, let us set, and it accepts an argument, right? Int, and it's having same name. So super can also this keyword is also used to avoid name collision. For example, I am using argument role, and role is also a data member. So if I will do this role equal to role, so he will be confused, compiler will be confused, right? Which role are you talking about? So that's why this comes into picture. So this will say I'm talking about this current class. Cool. Done. Then I will just, in that role, I will also use a println statement. Okay, I will print something. Let's say p constructor. That is a parent class constructor. Okay, constructor. Okay, cool. Constructor. Okay, done. That's it. We are not going to do anything in our parent class. Now for inheritance we need extends keywords, right? And what it extends? Demo, right? Cool. Done. Now what we will do, we will just create a constructor of GFG class, right? Herein it will accept argument, let's say int x. It's also a parameterized constructor, let's say int x, or let's use this name, you will get a clearer picture, role. Okay, now you see, is class GFG having role? No. So let's first create an object of GFG, the child class GFG obj, that's the object, okay, equal to new, right? That's how we create our objects. Now the constructor GFG will be called and with an argument of 10. Cool, done. Now I will write a println statement here, okay, let me rewrite it, println, okay, cool. Now I will say C constructor. What do you mean by this? What do you mean by this? Child class constructor, okay, constructor, done, cool. Now can I write here super? Just tell me, can I write this? No, I can't, because I already told you this has to be the first line of the, if you're trying to call the constructor of the parent class, it has to be in the first line. Cool, done. Now I will just use this role to call the parent constructor. Now what happens? Let's see. Let's try to debug it. Okay, so the first statement will be executed this, right? So the GFG, we create an object. With this object, the constructor will be called, right? Passing 10. Now this GFG will be called, right? So with the help of super, what will be called? The parent class constructor, that is demo. In that we are passing this role, that is 10. So 10 will be passed here. So with the help of this keyword, this roll number will be set. Done. And now we will use inheritance here. So we know that obj will be having what? Role, because it inherited from its parent. Now let's try to print it. Cool. Now what should be our answer here? System.out.println. Cool, done. Now let's try to visualize the output. Okay, so the first line that will be done after these several type of shifts, right? This GFG will go to this constructor will go to demo constructor, then in demo roll number will be assigned a value of 10, then the first line that will be printed will be P constructor. After that it will go back to the GFG constructor, it will print C constructor. Then after all these constructors are done, then the println obj role that we are trying to print will give us the 10 as output. Let's try to run this thing. What should be the output? P constructor, C constructor, 10, right? Let's see, give it some time. Yeah, cool. So P constructor, C constructor, 10. So you see, I used all those things that we studied up until this point, right? This keyword, super keyword, and the constructors that we have done already, right? And the one more thing, the inheritance, right? Cool. Now let's go back. You see, now this figure makes sense. Cool. Now let's talk about 4 types of inheritance that Java supports. We know that Java doesn't support multiple inheritance, right? But it supports single inheritance that we just did. Similarly, multi-level, hierarchical, and hybrid. Cool. Now the second pillar is done. Now the third pillar, that is polymorphism. Basically, polymorphism means to act differently on different inputs. Basically, when you are trying to send, that means in a naive way or in a layman's term, while if you change the input, the output changes. Make sense? Let me give you another example. Let's see this example. Maybe then things will be clearer. So method overloading is one thing with which we can achieve polymorphism. This type of polymorphism is done during compilation. So that's why method overloading is known compile time polymorphism. There can be multiple methods with same name. Now you see, you picture this thing. There are multiple methods with same name. Let's suppose we have a method named add, Now we have three methods with same name but different parameters. For example, the first add has two parameters, that is integer and integer. Second add has three parameters, integer, integer, integer. Third has two parameters, one integer, another float. You see, same name but different parameters, right? And different number of arguments as well. It can be different types or number of arguments. You see, herein when we talked about the first method, right, that was integer and integer, therein we have two arguments. The third one that I talked about was a method in which we have two arguments. So both of these are having same arguments but the type is different. One is having integer integer, another is having integer and float. You see, so we have three methods, all of them add but with different arguments or different types of arguments or number of arguments. Make sense? If you say no, I don't want to have different arguments, neither I want to have different types of arguments, can I do overloading with the help of return type? Let's suppose you say first and third are having two arguments, both of them are int. Can I do can I do polymorphism or method overloading with the help of return type? Let's suppose you say the return type of first one is integer and the another one is having double. No, you can't. This is not overloading. This is not overloading. Okay, just by changing the return type doesn't make any sense, so it doesn't support. Okay, cool, makes sense. It provides ease to programmer and helps it to understand the code, right? For example, let's say you want to add numbers, you want to add float type of numbers, you want to add strings. So you are having the same name method, right? Add for all of them, right? Add integers, add float, add string. Makes sense? Now let's see the demo. So herein we have a class named overloading demo in which we have multiply. In the first multiply we have int return type and two arguments, both of them are int. The second method, same name, right? We are overloading, right? So same name but three arguments, integer, integer, integer. Return type int, doesn't depend on return type. Let's skip that part. Okay, then we have third multiply with same number of arguments, that is two arguments, but type is different. One is having integer and double. Compare it with the first, integer and integer. Done. All the things are covered. Now you see the main method. Herein we created an object, then we called ob multiply with two arguments, ob multiply with three arguments, ob multiply with one integer argument, one float type of argument. Cool, makes sense. Then the output of all these statements is 1545 and 16.5. Cool, let's try to implement it quickly. Just a second. Yeah, so do we need this? No, we are trying to do compile time overloading, so no need of this as well. Let's stick to this thing only, that is overloading. So let's say int add int, let's suppose a comma int b, right? Now this thing, what it does, it returns the addition of these two numbers, a plus b, return a plus b. Cool, done. Now overloading means same name, right? This also having integer return type, I don't care, right? Now add, let's suppose int b having single argument, or let's suppose a, and then this returns 2 into a. Cool. Now what we will do here, we'll just create an object. Done, object is created, and then what we will do, we will call this add method dot add, and then what we will pass 2 and 3. So what we will do, which method will be called, which add method will be called, first one, right, with two arguments, right? And what it will do, it will do 2 plus 3, that is 5, and that will be printed. Similarly we will call it again, right? That's what beauty of overloading is. Same name, but now we are calling it with a single argument which just doubles it, that is 2 into 2, 4. Now what should be the output? 7, right, and 4. Let's run this thing. You see, this all thing happens during our compilation. Right now, it will be compiled and the code will be printed. Okay, extends demo. Yes, we removed the demo part. Okay, cool. You see, debugging is very important. If you find some error, let's suppose I got this error, right? So I removed all the demo part which I used earlier, right? So now I can easily find out. You don't have to be worried that I got this. Now what should I do? Just read the error and change your code. Okay, it's very simple. Java is very simple. Okay, now let's run this again. Give it some time. What should be the output? 5 and 4. You see, 2 plus 3, 5, and 2 into 2, 4. Okay, cool. This is called method overloading. Okay, now this is a polymorphism that happens during compilation. Is there a way by which we can do it at runtime? Yes, for that we have method overriding. It happens when we inherit something from a parent class. I will show you. This is a runtime polymorphism. Okay, so it inherits something from parent class, then in the child class we just override the parent class method. Okay, now let's see the demo. You see, parent is having hobbies method, right? It says reading books. Child extends it, right? Inherits, right? It's parent. Now it's having also the same method, same name. One thing you have to be very careful about, it has to be exactly same. If hobbies is having an argument, this hobbies should also have an argument. Okay, you have to just replicate it. Only you have to just change its body. Okay, now we are printing traveling. Then we created an object, so it should give us the output as traveling. Let's quickly go ahead and implement this. Java is really fun. I hope you guys are enjoying. So now what do we need? We need a class that is demo, and it's having one method. Let's suppose it's having void. Then let's name something it fun. Let's name it fun because Java is fun. Makes sense? Now system println. Let's do println. Now what is doing? Let's suppose parent. Let's call it parent. Okay, parent. Okay, now we use extends keyword to inherit. For inheritance, what are we inheriting? Demo. And now this demo will also have the same fun. Copy it, paste it. Cool. Now we just write in place of parent, what we will write? We will write child. Okay, cool, done. Now what we will do, we'll just call this method. Let's remove this line. Done. Now let's call fun. Simply fun is called. Now what should be the output? Are we calling the parent class method fun or the child class method fun? The child class method fun. So what should be the output? Okay, we have already printed it, so let's remove this thing, right? Because we are using the println statement on the function as itself. Now let's run it. What should be the output? Child, right? Give it some time. Cool. This is runtime polymorphism. During runtime, this thing happens. So this is all about what? Method overriding. Runtime polymorphism, we checked compile time polymorphism. Both of these are polymorphism, which is the third pillar of object oriented programming. Cool.
Now abstraction, the final pillar, right? If a method doesn't have its implementation, then it's known as abstract method. Okay, we will see what do you mean by this line in the next slide. But for now, let's see. I have defined a method and I haven't done any implementation on it. I just have declared it. Okay, no body is given. So that method is called an abstract method. Class having one or more abstract methods is known as abstract class. So let's suppose if there is a class and in which there are some normal methods and there are some abstract methods or abstract methods are present there. So that class which contains some methods which are not abstract and which are abstract is called an abstract class. Okay, it actually implements abstraction to certain extent. What do you mean by this certain extent? So since there are some methods which are not abstract, that's why this word certain extent has been written here. Okay, this certain, there is not proper 100% abstraction, but some part has been abstracted, right? Abstract keyword is used for declaring abstract class. Abstract class can have abstract and non-abstract methods, right? And it can be instantiated. Okay, so since there are some methods which are not abstract, so we can create objects of this class. Okay, rather it has to be extended, right? It has to be extended, and the abstract methods have to be given their implementation. So how we implement this, we have to use the extend keyword, and then once we have extended that class in some other class, right, we are using again inheritance, right? So once we have inherited the parent class, right, inherited the parent class in the child class, right, now in the child class we have to define its body. Implementation has to be given. So now let's see the demo and the things will be much clearer. So here's the abstract class, right, keyboard. In that there is abstract method called working, right? There's an abstract method, and there is another method called name. So you see why it's abstract, right? There are some methods which are abstract, right? There's an abstract method working, and there are methods which are not abstract, that is name, right? If that is the class containing such properties, right? Some methods are abstract and some are not. It is called abstract class. Okay, now the HP class extends this keyboard, right? You see, now once we have extended this keyboard class, right, we have to implement the abstract method. If we don't, we will get an error, right? So working has to be implemented. You see why do working, and it has to be same name as, right, as in given above, right? Then we just gave its body. Implementation has been given in the class, in that HP class, right? Then in the main method, then once we created an object of HP, when we called working, it should be it is shown the message, this is a HP keyboard. And then when we called the name method, it's called, this is a keyboard component. Okay, you see how we implemented this abstract class here, right? Abstract class is nothing but a class containing abstract methods and non-abstract methods. It's not 100% abstraction, right? But to some extent we are able to do abstraction. Now you might be thinking, yeah, we are doing this is not abstraction. How we can just do 100% abstraction? For that we have an interface. So interface enforces 100% abstraction, right? All the methods, you see here, if you see in this class keyboard, there were some methods which were not abstract, but in the interface all the methods are abstract by default, and this is not necessary to write abstract. This is not necessary to write an abstract keyword while declaring them, right? So what do you mean by this line? When we are talking about an interface, we know that all the methods are abstract. Okay, there's no point that there will be some methods which are not abstract. So writing in abstract in front of that method is not, it's not mandatory, right? So we know by default. Okay, compiler implicitly, right, automatically adds a public abstract in front of every method of an interface. So you don't have to write it, compiler will do it for us. Okay, what will he write? He write public abstract in front of that class. Okay, if you see that there's an interface toy written in this, right, wherein we have defined two methods which are abstract, public abstract. We don't have to write that, compiler will do it for us. Okay, public abstract. And what are the methods? Two methods, start and run. Implements keyword is used by the class that wants to use it and has to give definition for every method. Once what we did, we just use the inheritance concept here again. Now once we inherited this class, this type of interface, right, this is an interface, right? So once we have implemented, we have to use implements keyword instead of extends, because we are inheriting interface, right? While implementing interface methods, we have to be specific that public access modifiers is must. So the methods that have been defined will be public. Okay, these methods were that interface methods has to be public. Okay, and we have to be sure that we have to define all the methods in that class which is inheriting it or which is implementing it. A class can implement multiple interfaces, which enables a sort of multiple inheritance, right? In the starting of this session, we talked about how we will be able to do multiple inheritance, right? Java doesn't support multiple inheritance, but with the help of interfaces, we can do it, okay, if you want. Now let's see the demo. So there's an interface toy in which there has been two methods written, void start and void run, right? The return type is void. So you see, I haven't written any abstract in front of them, right? Which was in case of the abstract class. Rather, a compiler will explicitly, will automatically, rather implicitly. You see, we haven't written public abstract in front of these two methods, right? But our compiler will implicitly define what or write public abstract in front of these methods. Okay, now a car implements toy, so we have to define our body or implement those methods inside of that class car. Okay, and we have to make sure that these methods are public. Okay, that's why it's written public void start, public void run. Car started in the method of start, cars is running, right? Then we defined an interface demo in that class. We just called a main function, then we created an object of car, and then we just called both these methods start and run. Okay, this is how we implement interface. Now let's quickly go ahead, and this is very important topic. So now let's quickly go ahead and check its demo. So now what we talked about here, right? Just give me a minute here. Okay, yeah, cool. So now let's create an interface. So what we write, interface. Okay, just a minute, interface, right? Interface keyword. Now we created an interface, right? What do we call it? Let's say we call it a car. Okay, car is an interface. Okay, it's written car. Okay, we created in car, right? So we have created a class car, right, which is an interface. So in this, there should be methods, only methods which are abstract. So we don't have to write anything instead of we don't have to write abstract keyword here in front of these methods. We just have to write void. Let's say the method name is run. So this is the method, and that's it. There is no body for it. Okay, it's an empty method, right? That's what we do it, right? I talked to you, right? This is the method. Okay, so this is the method, that's it, void run, and there is another method start. Okay, these two methods are abstract, okay, because it's an interface. Now when we're trying to inherit this method, we just have to write implements. Okay, implements keyword, and what does it implement? Let me rename it. It's a car. Okay, and it implements car. Now once this method has been implemented, right, this method has been implemented by this class, it's explicitly, and I have to define some bodies. If I'm not defining any bodies for these methods, then there will be an error. So I have to explicitly define these methods. So I have to also write public in front of them. Okay, it's very important that I write public in front of them, else it won't run. Okay, so I have to define body run. Okay, and then what I did, I just write system. Okay, just give me a second, and there is a snippet. Okay, print message here, print ln, right, and then we just write run. Okay, and that's it. Now we have also, if we only defined one single method and second has not been implemented here, then also it will give an error. It has to be explicitly both the methods. Okay, both the methods has to be implemented. Then we will write start. Okay, that's it. And in the message, let's change the message to start. Okay, done. This is how we do it. Now we created an object and then we just call these methods. Let's remove these lines. And now what we will do, ob dot, what is the method? Run. That's it. And ob dot, let's check that as well. Start. Ob dot start. That's it. End of statement. Okay, end of statement here. That's it. Both these methods have been defined, and this is how we implement our interface. Okay, let's run this thing and see what is the output that we are getting. Yeah, run and start. This is how we implement our interface. So there is two things that you have to keep in mind. You have to define only methods which are not, I mean to say, whose body is not defined. Okay, only those methods can be defined in an interface. You can't have a method just like in when we're defining abstract classes, right? In that there were some methods which were abstract and some were not. Here all the methods will be abstract, and you don't have to write public abstract in front of it. Okay, or a compiler will do it for us. Okay, and once we are implementing, we have to implement both these methods in our classes, right? I'm repeatedly saying that both these methods, if there are three methods, all of the three must be implemented, and we have to write public in front of it. If we don't, then there will be an error. Okay, that's it. Now let's go back to our code, and this is done, right? Now let's talk about exception handling. So exception handling is an abnormal condition that may happen at runtime and disturb the normal flow of the program. What do you mean by this? Maybe sometime you are writing some program and you did an operation wherein you just divided some number by zero. Dividing any number by zero isn't that normal? Is that normal? I am just saying. Is that normal if you're trying to divide anything by zero? No, it is not, right? So dividing anything by zero will give unexpected results, right? So during that time when we accidentally do such things, we need exception handling. Okay, so we can handle exceptions in order to ensure that our code gets executed normally. There are two major categories of exception, right? Checked and unchecked. So in checked, those exceptions are called checked at the exceptions which are called checked are checked at compile time, right? Okay, these exceptions are checked at the compile time, and the unchecked exceptions are checked at runtime. Okay, so there is checked and unchecked. Checked are checked at compile time, unchecked are checked at runtime. Okay, simple. For example, IO exception, class not found. These are all IO exception, class not found. These are all examples of checked exception. Now, what are the examples of unchecked exceptions, right? Which we check at runtime, right? So arithmetic exception, null pointer exception, all these exceptions are unchecked exceptions. So the basic syntax is try and catch. So basically, whatever we think of that this statement might give some exception, we put it in a try block. Okay, and in catch we will catch that exception and we will just print that thing. So let's quickly go ahead and check the keywords in exception handling. So some of the keywords that we are going to use here in this session are try, catch, finally, throw, and throws. Now let's try to implement try catch. Okay, so what do you mean by try catch? Try block contains the code that might throw an exception. Make sense? We don't write anything extra here in try block. Okay. After the exception will get executed. If the exception occurred, catch block is used to catch the exception thrown by the statement in the try block. Okay. So for example, if you can see the example below, what I'm using. So in the for loop, if you have defined it syntactically correct, right? Its syntax is correct, right? And what you want to do is what you are trying to do, right? If what you are trying to do is what you want to do in the for loop, then it will work fine. Now, there is an exception that might occur when you're trying to divide. You see, a will be divided first by 3, then a will be divided second by 2, then a will be divided by 1, then a will be divided by 0. So at that time the try block will execute. Okay, so because it's an exception, what the try throws it to the catch. Okay, arithmetic exception, right? This is an arithmetic exception when we are trying to divide anything by 0. That's what we get in that. Then we are trying to print that exception. We got java.lang.arithmetic exception by 0, that dividing by 0. We are trying to divide anything by 0. So catch block must follow the try block. Okay, else it will give a compile time error. So every time if you're using try block, then catch block must follow it. Okay, catch block is used to catch the exception thrown by the statement in the try block. So this is the program to implement try to implement try catch. How we implement try, how we implement catch. Okay, there can be multiple catches which should be placed after the child to parent in order to get the desired output, right? So if you're trying to implement multiple catches, that can also be done. So this must follow. For example, what do you mean by child to parent in order, right? So there should be an order while you're implementing this catch. For example, there is a general exception, right? That is called this exception class that is written here, exception E. This is the parent class. Okay, now this exception is a child class. That arithmetic exception is the child class of this exception class. Okay, so the exception class that is written is the parent. Okay, parent of every exception, right? So if we have written instead of this arithmetic exception, we have written exception E. Then after that, the catch, after we have written multiple catches, the next catch we wrote is arithmetic exception E. That will give an error because it has to follow. Child must come first, then parent. So if we want to implement multiple catches here, then the arithmetic exception E should be first in the catch, and then the exception E in the next catch. Okay, this order must follow. Now finally, so this code contains the code which will be executed no matter if the exception is thrown or not. Finally generally contains the code of file release, memory cleaning, and all those things, that the memory release code and memory cleaning, these type of codes are done in finally. So if there's an exception that we are again trying to divide 10 by 2, then there is no exception, right? There is no exception has occurred, but the finally statement will always execute. So there will be an exception, there will be no exception in this case, right? But the finally statement will be still executed. You see the output, I am finally. So this is what we use finally for. If you want something to be executed, no matter if the exception has occurred or not, finally will still be executed. Okay, now the throw keyword is used to explicitly throw an exception which normally doesn't throw an exception. So for example, if you explicitly, that is not automatically, herein we were automatically throwing an exception in this case, right? It automatically throws the exception. But if you yourself want to throw an exception, that throw is the keyword that we have to use. For example, in this class, what we wrote, that if the age is less than 18, right, then throw an exception. That's how we do it. Throw new exception, right? In the try block. If the age is less than 18. Okay. Now, if it's not, then there will be no exception thrown. So If you want explicitly to throw an exception, throw is the keyword we use. And how we use it? Throw new exception, right? We use the new keyword here, okay? Because we are generating an exception, right? That's how we do it. Now finally we will talk about throws. So throw is basically, it says a sort of exception the code can throw and relies on the caller to handle. So herein we are not explicitly throwing an exception, rather it is upon the handler, the caller, that defines the exception or that throws the exception. For example, here what we have written, try function, then we call the function and we pass the argument 10 in it, right? And we have also passed an argument 0 in it, right? So once the function has been called, in A there will be 10 first, then the system will give 10 divided by 10, right? There is no exception. So no exception is thrown by the function that has been defined. Now if 0 has been sent, now the 0 has been sent in this function, right? A contains 0, so 10 divided by 0, it's an exception, so it will throw an exception, right? You got the point, right? The exception of the code can throw, basically throws is responsible for handling the caller, right? When 0 has been sent, so this function is responsible for throwing an exception. What we just have to write in front of that function, throws exception, right? Then the exception will go in the catch block, and can't divide by 0 is the message that we will print, okay? This is how the throws works. So throw basically says what sort of exception the code can throw, okay? And relies on the caller to handle it. So the caller defines it and handles it, the caller function, okay? For example, here function func, okay? This is all about exception handling. Now the last topic of this session, and we are about to conclude this session, is the string. String, why we have defined string here? Because it is in most of the programming language, string is not data type, right? But in here, string is a class which defines, wherein if we have to define strings, we have a class associated with it. With the help of this will also basically is a sequence of string. We all know is basically a sequence of characters. It's a class in Java, right? There are two ways to create a string hello, without the new keyword, and with the new keyword. So we have special memory termed as string constant pool inside the heap, right? In the first way, copy is created in the heap and string constant pool. So these two ways are with these two ways we can define a string, right? String str hello and string str equal to new string hello. So with these two ways we can create a string, but there's a difference, right? The first way, that is str hello, that we wrote, creates a copy is created in heap and as well as in string constant pool. So if it's not already there, what do you mean by this thing? So if I wrote str hello, right, then I again wrote str hello. So in string constant pool, first time when I wrote str hello, the copies will be created in both heap and the scp, that is string constant pool. So next time when I created hello, so it will check if it's present already in the scp, then it will not be created, but in the heap it will be created, okay? You see the difference? But in the second way, it's always created in the heap only. Copy is created always in the heap. So if I create str new string hello with the help of new keyword, a copy will be created only in heap. So this is the only difference between these two types of ways, okay? In the first way, when we don't use the new keyword, copy will be created in heap as well as in scp if it's not present in scp, that is string constant pool. In the second way, it will always be created in the heap only. So string can also be created using a character array. We all know that char, if we write a character array ch, then hello, we will put values in it. We can also define it in such a way. We can also use new keyword, okay? Then what we will do, we will just put that array into the string, okay, with the help of new keyword. String is immutable. That means once created, it cannot be manipulated. So if we want to manipulate it, we have to reinitialize it, okay. You can't say that you will use str, I mean to say str plus hello, I mean to say, if you used something, that means you concatenated string without assigning it to that value, you can't do it. String is immutable. Once created, cannot be manipulated. You have to reinitialize it again. Now, string comparisons. There are three ways we can I mean to say, if we want to compare two strings, there are three ways with which we can do it. So the first is equal to sign, double equal to sign. Checks for the same reference. If both the references are same, then this will give an true output. Then also there's one method with which we can check if the content is same or not. That is dot equals. Okay. Then the final is compare to. It compares content lexicographically. I mean alphabetically. Okay. If the number is positive, then string 1 is greater. Okay. If the number is negative, string 1 is lesser than string 2. And if it gives 0, then both of the strings are equal. Okay. So these are some comparison methods in strings. So now let's talk about the demo of these methods that we used. You see, we defined a string with the help of new keyword. So with the help of new keyword, memory, a copy will be created in a heap, right? And then we defined two two strings, s2 and s3, right? And we have assigned a value cat to both of them. What will happen here? When the first time s2 has been declared or initialized, a copy will be created in heap as well as in scp. The next time when s3 comes, it will check, oh, cat is already there. So in scp, it won't be created, right? And it will be created only in heap. So now when we use double equal to sign, what will it check? It will check for reference, right? Are the two references same? No, because one has been created in these are two different things, right? It has been created in scp and it has been created in heap. So the references are different. But if we check s2 equal to s3, right? Are the references same, right? This is how we check it, right? Double equal to checks the reference. So yes, reference is same, because in scp only one copy has been created. Are s1 and s3 same? No. S1 and S2 dot equals checks the content. So if you do dot equals with any of these three, you will get true, right? Because the content of all these three strings is same, right? Dot equals check this content. Now compare to. So S1 dot compare to S2. So the comparison, once it is done, what will be the answer? Will it be positive, negative? No, it will be 0, because both of them are equal. Right? Lexicographically, I mean to say alphabetically, or they are having same characters as all of the strings have same characters. So that's why when we use compare to method, it will give 0. Okay, that's the method. Now let's talk about string, some of the important methods in string. So you have seen, if we want to change, we want to check the length of the string, right? That, for example, in the above string defined, today is Monday, this is a string defined. So if we want to check the length of this string, I mean how many words are in this string, what we will use the length method. Okay, we just have to write str.length, we will get the length. So the length of this string is 16. So that's what the output is. Okay, now we can also change this string to lowercase. That means all the letters will be written in lowercase. So we just have to write str.lowercase. That's it. All the words in this string will be converted into lowercase. So you see, T is capital in today, but in the output T is small, right? All the rest of the words are in lowercase, right? Now if you want to change it to an uppercase, right, all of these words must be in uppercase, you have to use to uppercase. So you see in the output, today is Monday, right? That's how we do it. Now, if we want to check if certain part of a string is present in our, for example, if certain thing is present in this string, for example, we checked if str contains, does this string contains is Monday? Yes, it contains, right? Today is Monday is present in this string. So if we use dot contains, we can check. Okay. Dot contains helps us to check a certain keyword or certain words in the string. Now, what is the index of Monday? We want to know the index at which position is Monday, right? So you just have to write index of. So the index of Monday, if you try to count, this thing is 9. So today is 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So it is present at index 9. So you can check if you want to find out the index of certain type of strings, you can do it, right? And now if you want to check substring, so if you want to check if this substring is, what is the substring that you want to know from this position to this position, I want to know what is the content in the string. So what you will use sub str. So from 4th to 8th index, we will get the output. So 0, 1, 2, 3. So 4 will be included. So y is included, right? Indexing starts from 0, right? We all know that, right? So today is 0, and then O is 1, D is 2, A is 3, Y is 4. So 4 is Y. So that's 4, 5, 6 and 7. And then space 8. So Y space is the substring that we were looking for, because we have defined the indexing in that way. 4 to 8 will be excluded. Okay. Now if you want to replace something, we just have to write the word that we are replacing. The first argument is that word, and the new word that we are going to replace that older word with is going to be the second argument. So str dot replace Monday with Tuesday. So Monday will be replaced with Tuesday. That's it. These are some important methods that we are going to use regularly in our day-to-day lives or in our day-to-day programmings, right? Whenever we do competitive programming, these are very important methods to play around with strings. Okay.
Now let's see what are the takeaways of this session. So in this session, first we learned about how to set environment variables. We went into the control panel, right? And then we pasted the paths of JDK and JRE in that with the help of class and class path variables, right? We talked about them. We talked about JDK, JRE and JVM. What is a virtual machine, runtime environment, and Java development toolkit, right? We talked about data types, the 8 primitive data types, right? Operators, relational operators, bitwise operators, right? Logical operators, arithmetic, assignment. We talked about all those things, right? Conditional statements, if, else, right? Loops. We talked about loops, while loops, for loops, and the branching statements, right? Return, and the other two branching statements, which are break and continue, how they are different from each other, right? We talked about classes and objects, how object is an instance of a class, right? We talked about super and this keyword, how we used it in our inheritance, right? Which is the first one of the 4 pillars rather of object oriented programming, right? We talked about encapsulation, how we were able to do it with the help of classes, right? We talked about inheritance, right? All those things. We talked about runtime polymorphism. We talked about compile time polymorphism, which is the 3rd pillar of OOPS. And finally, the 4th pillar, which is abstraction. We talked about we talked about 2 ways, right? The abstract class, which is not 100% abstraction, rather it is somewhat related to abstraction. We talked about interfaces, which is 100% abstraction. So all the all the 4 programming pillars, right? The object-oriented programming pillars were covered in this session. And finally, we concluded our session on strings, and we talked about some of the methods that are extensively being used in day-to-day life of a programmer. Okay, all those things were covered in this session. I hope you enjoyed this session. Thanks a lot.